sa Anachem, pero medyo may relation to sa subject natin. Okay? So mamaya makikita natin kung ano yung importance ng statistics in chemistry. Okay? So yung equation dito, madali lang. At ganito pala yung flow natin today. So sa PowerPoint, makikita natin yung usual calculation. Then later on, tuturo ko yung shortcut sa calculator. Tuturo ko yung shortcut sa calculator and kung paano to gawin sa Excel. Okay? So, kasi kapag magko-quiz kayo, hindi ko naman alam kung ano ginagawa nyo. Kung kayo ba nasa laptop, then you can use the Excel. Kung kayo ay kung sa cellphone kayo nagko-quiz or sa iPad ninyo or sa tablet, pwede calculator method. Okay? Para mabilis. Okay, so let's start. Okay, so first of all, what is the relation of statistics sa ating subject sa analytical chemistry? Okay, so remember that analytical chemistry involves measurement. No? So ibig sabihin, may mga mini-measure tayong properties of matter. So every time we do measurements, no, according to statistics, there are errors involved in that process. Okay? Kunwari, nagtitimbang ka ng chemicals, may errors na involved doon. Okay? So, si statistics, siya yung magte-tell kung anong errors yung pwedeng involved sa inyong measurement na. So, pwede niya i-infer na mali ka or mali yung methods mo o kaya random error lang talaga siya. Okay? So yung statistics, this will give us an idea that there are errors in our measurement. No? So some errors are okay. No? They are innate. Ibig sabihin, nasa sistema na talaga yung pagiging error niya. So nasa sistema na yung error, and that's okay lang. And some errors are bad. So when you say bad errors, ito yung mga pwede pa remedyohan. Okay? So, in order for us to know if may error tayong okay or may hindi tayo okay na errors, we will use statistics now. So, yan. Also, we can also use, excuse me, hindi ko lang kung naririnig nyo yung aso ko. Okay, medyo nakaka-bother. Anyway, so other than identifying the errors, we can also use statistics, no, for us to have an idea whether our hypothesis is correct or not. No? So this type of statistics called ANOVA or t-test then, okay, so pwede yun sa atin magbigay ng idea kung tama ba yung hypothesis natin or not. However, for the purpose of this discussion, we're not going to do that. So, hindi tayo magti-test, hindi tayo mag-ANOVA, only the basics of statistics. Statistics lang. Okay? Yung mga ganong topics, yung mga t-test, ANOVA, that will be discussed in your biostatistics na lang. No? So, I don't know kung anong SEM yung biostat nyo, pero dun yun makakukwento. Okay? So, basics lang tayo. So, ano yung basic na statistical tool that we can use in analytical chemistry? So, the most basic statistical tool is called the measures of central tendency. So, when you say measures of central tendency, we are checking kung saan ang middle ground ng ating observations or measurement. So, we are seeing kung ano yung pinaka-average ng mga data na makukuha natin. Okay? So, there are three tools involved sa pag-measure ng central tendency. So, yun yung mode, yun yung median, and yung mean. Okay? So, punta tayo sa pinaka-basic, yung mean. So when we say mean, that is just the average, okay? So that is the arithmetic average of your values. And ito sa formula, x bar. So pag makita kayo ng x bar, average lang yun. So that is the sum of all your measurements divided by the number of measurements you have. Okay? So ganun lang. No. So again, mean, that is the sum of all your measurements divided by the number of measurements you have. Okay, so basic lang yan. Alam ko, alam nyo na yan. So for example, we have this data here. We have the water hardness data in parts per million. Our task is to obtain its average. Okay, so ano gagawin nyo? You will add your data. I-add mo lahat ng measurements mo. So we have 310, 314, 325, 300, and 327. So basically, you will add them. So you will have the sum of x. Okay? Yan yung sum ng inyong measurement. So please bring out your calculator. Kasi marami tayong pinipindot sa calcio ngayon. So 310, 314, 325, 300, and 327. So the sum of our measurement is 1576. 76. Ganyan na lang. So that's the sum of x. Okay? So yan na yung sum ng measurement. For us to obtain the mean, ano yung formula ulit? Sum of x yan divided by the number of measurements you have. No? So that's 1576 divided by how many measurements do we have here? 5. No? So yan, 1, 2, 3, 4, 5. So basically, you just divide them by 5 to obtain the mean. So that will be 315.2 ppm. Okay? So ganun lang ka-easy. Diba? Dali lang, diba? Next one will be the median. So when you say median, this is the middle result of your data. Okay? However, for you to get the median, you have to arrange your number from lowest to highest. Okay? So if your data points are odd in number, then the median can be evaluated directly. Paano yun? For example, we have this number here, 310, 314, 325, 300, and 327. You're going to arrange that from lowest to highest, okay? Then, anong gagawin mo? Since odd number yung iyong measurement, 5 yan, so odd number, your median can be obtained easily. Paano yon? Gagawin mo, by pair mo tatanggalin yun na sa magkabilang dulo. So yung 300 and 327, cancel mo yan. 310, 325, cancel yan. And then kung ano yung matira sa gitna, that will be your median. Okay? So ganun gagawin. Paano uli? You arrange your number from lowest to highest and then you check the middle value. Okay? So kapag odd number yan, kung ano yung nasa gitna nila, yun na yun. Okay? So gagawin mo, remove the data points at each end, no, until you arrive with one number in the middle. That is if odd yung dami ng measurements mo. What if you have an even number of measurements? Paano kapag even? Ganun pa rin. Okay. So you have your data here. You arrange this from lowest to highest. Okay, so arrange them from lowest to highest. Lowest, highest, then cancel each ends. No? Cancel mo yung mga nasa dulo. Okay, so yan. Then proceed ka sa susunod na magkabilang dulo. And then, kapag even number yung data mo, ang ending mo ay may 2 digits sa gitna. Okay, so you have 2 digits in the middle. For you to obtain the median, gagawin mo lang yung, kunin mo lang yung average ng dalawang yan. Okay? So, yun yung difference, no? Kapag even number ang data points, gagawin mo, kung ano yung matira sa gitna na dalawa, kukunin mo yung average nila. That will be your median. However, kapag ang iyong data ay odd, kung ano yung nasa gitna, yun na yun. Okay? So, yan. So, again, median is the center or the middle result, no, ng inyong data when arranged from lowest to highest order. Okay? So, ganun lang. And mode, when we say mode, this is the most frequent value. Okay? So, pag sinabing most frequent value, kung sino-sino yung mga pinaka nauulit, no? Okay, so sometimes our data can have one mode. Okay, so ibig sabihin isa lang yung kanyang nauulit na number. Pwede naman maraming nauulit na number to a same degree, no? Kunwari, yung isang number na ulit 3 times, tapos yung isang number na ulit 2 times, edi yung number na naulit 3 times, that will be your mode. Kasi sabi natin most frequent. What if tie sila? Kunwari, sir, ito pong number na ito, letter A, kunwari yung number na yon, um, 3 times siya na ulit. Tapos yung isang number, 3 times din siya na ulit. So, ano po yung mode namin pag ganun? So, the two are your modes, no? So, ang mode kasi natin, pwedeng isa lang yan, pwedeng dalawa, pwedeng tatlo. Okay? So, kaya may term tayo na unimodal, bimodal, trimodal, etc. Okay? Basta kung sino yung pinaka nauulit lang. No? Pag pantay, then you have two modes. No? Pwedeng 3 yung modes mo, pwedeng 4. No? So, although that's rare na. Okay? Yun lang. And then, ano ba yung matutulong nitong mga to? Ano ba yung masasabi nila sa atin about our measurements sa chemistry? Okay, so ang purpose ng mga ito is to tell us whether our data are accurate and or precise. No? And or. So, pwede kasing accurate pero hindi precise. Pwedeng precise pero hindi accurate. And pwedeng parehas okay, pwedeng parehas hindi. No? Okay, so when we say accuracy, sa ating measurement, we are pertaining to the closeness of our measurement with the true value. Na kung gaano siya kalapit to the true value. And it can be measured by errors, no, or percent error. So how do we solve for percent error ba? Okay, so you just check kung magkadikit. Let me write that in equation na lang. So how do we solve for the percent error? So that is just your data minus the true value divided by the true value, okay? Times 100. Kapag malaki yung percent error, then that means your data isn't accurate, no? So ibig sabihin hindi ka accurate. Pero kapag mababa ang percent error, that means your data is accurate, okay? So again, accuracy can be measured by means of percent error, okay? Or error. Okay. When we say precision, ito yung pinaka-focus talaga natin, precision. Kasi wala naman tayong true value for now. Okay. So, sa ating measurements, wala tayong true value na given. So, hindi natin matitel yung accuracy talaga. No? So, dito tayo sa precision. Okay. So, when we say precision naman, that is the closeness of your measurements. No? So depending on the closeness of your measurements, it can be highly precise or not. No? And how will we measure the precision? We can use the measurement for spread. When they say spread, gano'n kalat yung data mo. And that can be measured using standard deviation. If the standard deviation or the spreadness is high, then your measurements isn't precise at all. Anong meaning nun? Di hindi ka precise, no? Pangit ka mag-measure. Ganun kasama tong stats na. Sasabihin niya, pag mataas yung inyong standard deviation, mataas yung spreadness nyo, pangit yung measurement mo. So, with that idea, pwede mo malaman saan ka nagkamali. No? Nasa next slide yan. Pag mababa naman ang inyong spreadness or mababa ang inyong standard deviation, that means you are good in measuring your stuff. Okay? Magaling ka mag-measure. No? So you are skilled. No? Pag kayo nag-laboratory na in the future, matitest yung accuracy and precision nyo sa tulong ng QA/QC, quality assurance or quality control. No? So, doon yung malalaman na statistics is used talaga sa industry, no? So, ganun lang. Okay. So, anyway, ano ba yung mga pwede natin malaman dito sa stats, no? Ang pwede natin malaman is that ano ba yung mga errors na pwede nag-cause ng spreadness ng data natin, okay? So, again, ang focus talaga natin dito ngayon ay precision kasi wala tayong true value for now. So, Suppose you have a set of measurement for you to tell if your measurements are precise or not, then you have to determine the spreadness of data. Okay? So kapag mataas masyado yung spreadness ng data mo, there is something wrong. Pag masyado mababa yung spreadness niya, that's good. Okay? So by just looking at the spreadness or the error, percent errors sa inyong statistical tools, no, pwede mo malaman kung anong types ng error ang nagawa mo sa inyong measurement. So there are three types of error that we encounter in chemistry. Number one is the random error. Number two is the systematic error. And the last one is the gross error. So let's focus on the random error. This is also called indeterminate error. From the word itself, indeterminate, ibig sabihin, hindi mo na siya malalaman kung saan siya galing. Saan galing yung error na yan. Okay? Mahirap yun i-control. So, ibig sabihin nun, that type of error is innate. Ibig sabihin, andyan na talaga yan. And that's okay lang. Ito yung sinasabi kong okay lang na error, yung random error. So, ano yung mga causes ng random error? Yun yung mga uncontrolled variables sa environment. No? So, pwedeng yung temperature, nagpa-fluctuate masyado. So, yan, medyo hindi mo naman control yon unless gumamit ka ng aircon, no? Okay, pero hindi pa rin assurance na kapag may aircon sa laboratory, constant yon, no? So, yun yung mga random errors, something that is uncontrolled talaga, okay? Pwede rin naman yung sa inyong glasswares, sometimes it expands or contract. Yung degree ng expansion or contraction, that's variable. So, wala tayong magagawa. Andun na talaga yung error na yan, okay? Kasi wala namang instrument sa buong mundo. Wala rin naman glasswares na fixed talaga. Lahat nag-change, no? So, accompanied with the change is the error or the random error. So, yun yung mga innate na sa system mo. Andiyan na yan. Hindi mo na yan pwede makorek. Okay? So, yun yung random error. And that's okay. Okay lang yan. Okay? It is always present at cannot be corrected. No? Kaya nga may bell curve sa statistics, di ba? Kapag kayo nag-measure ng data, naka-curve talaga yan. Okay? Nakaganyan yung curve na yan. Medyo pangit lang curve ko. Okay, nakaganyan talaga yan. Naka-curve yan. So, kung ano yung nasa gitna, ano yung mga nasa central tendency mo, yun yung kinukuha mong value. Then, yung mga data sa dulo-dulo, yun yung mga pwedeng source ng errors. No? Yun, pwedeng affected sila by random error and the other types of error. So, again, pag sinabing random error, andyan na yan that cannot be corrected. Okay, so that's okay lang. However, punta tayo sa next type of error, which is the systematic error or the determinate error. When we say determinate error, pwede mo ma-determine. Okay, so that is an error that can be determined. Okay, so ano mga types of systematic error? Okay, so there are three types of systematic error. Number one is the instrument error. Pwede yung instrument nyo, may mali siya. Okay, ano ba yung mga examples niyan? Okay, so excuse me. Kunwari, you are doing spectrophotometric analysis, tapos yung instrument mo, hindi mo na siya nakalibrate. Again, lahat ng instrument kinakalibrate. Or let's say yung pH meter, hindi mo nakalibrate, then it will give you errors, no? It will give you false results. Okay? So, compared to the random error, since ang systematic error ay determinate, alam mo kung ano yung may error, you can correct that. Okay, so for instruments, for you to correct that error, the systematic error or the instrument error, pwede mo i-calibrate yung instrument. Okay, o kaya kapag luma na talaga yan, huwag mo na gamitin. Bili ka na lang ng bago. Okay, so yun yung mga instrument error. Also, there are times na because of the fluctuating voltages, okay, kasi ako napapansin ko yun paggabi, no? Pag kunwari matutulog ako, naririnig ko yung ventilador ko, bigla-biglang bumibilis. Tapos mamaya bumabagal siya. yung ganong effect na yon, that is because of the fluctuation in our electrical supplies na sa ating electrical supply. So yun, pwedeng masyadong tumaas yung voltage, that's why mas bumilis yung ventilador. Pwedeng bumaba yung voltage supplied by Meralco, so bababa yung bilis ng fan. Okay? So nangyayari talaga yan kasi naka-alternating current tayo. So it fluctuates over time. So sa instrument sa chemistry, it could also happen, no? Yung fluctuation sa voltages, no? So kung ganon, anong pwedeng remedyo for that? Pwede bumili ka ng AVR or automatic voltage regulator. Yung mga nasa desktop PC. Yung AVR na yon, that helps to keep the voltage constant, no? So that the instrument will not be destroyed by the fluctuating voltages. Pwede rin naman siya makatulong na maging constant yung measurement ng instrument mo. Kasi kapag biglang tumaas yung voltage, baka masyadong maging sensitive yung instrument. Okay, so yun yung mga possible reasons. Okay, so yun yung mga ganaps with our instruments. No? Mga masaselan yan eh. Kaya nga, sometimes, pag kayo nakapunta na kayo ng research laboratories, no, makikita nyo, for each instrument, may sarili siyang kwarto. May sarili siyang room. Okay, so for example, sa PNRI, Philippine Nuclear Research Institute, dun kasi ako nag-OJT before, may sariling room yung Fourier transform infrared spectrometer. May sarili siyang room yung FTIR. Ginagamit namin yun to determine the type of bonds present in your sample. So may sarili siyang kwarto, and yung kwarto na yon, naka-aircon yon, fix yon at constant temperature talaga, and meron siyang voltage regulator. Okay, so para kung ano yung ma-measure niya, yun na yan. Okay, so hindi na pabago-bago yung measurement niya. So kunwari gas chromatography, naka-separate na room yan, no? So yung room ng gas chrom, ganun din, may sarili siyang AVR, may aircon to maintain the temperature so that the instrument error will be lessened. Okay? So yun yung mga ways to address the instrument error. Bigyan mo ng sariling kwarto yung room, yung instrument mo, lagyan mo ng aircon, no? Tapos gamitan mo ng AVR, no? So yun yung mga um, usual stuff na ginagawa namin for instrument errors to be minimized. Pwede ka rin mag-calibrate, ha. So kunwari timbangan 'yan. Hindi naman kailangan ng timbangan ng aircon, no? Ang kailangan nun calibration. Kunwari pH meter, hindi rin nun kailangan aircon. Kailangan nun ay calibration. Okay? So as long as ginagawa mo 'yon sa iyong instrument, then good ang inyong magiging measurement. Bababa yung systematic error nyo. And as a result, mas magiging precise ang inyong measurement. So the next type of systematic error would be the method error. Okay, so ano yung method error? From the word method, ibig sabihin yung ginagawa mo. Okay, so for example, you are analyzing this substance, then mali yung ginawa mo na procedure, mali yung magiging result mo. So systematic error yon. Okay, nasa system yung error. Okay, so yung methods, sometimes they are ideal, sometimes they are not. Okay, so kaya nga sabi ko sa inyo last time, yung pinakauna pa lang, when doing chemical analysis, kailangan alam nyo kung ano yung kailangan nyo gawin. Okay? Because if you do not follow the correct methods for that type of analysis, then most likely your data will be spread out. Okay? Tataas standard deviation nyo. So that means may error. Okay? Malaki yung error. Okay? So yan, that's why we have to use the correct methods. So yan. So yan. And then the last type of systematic error will be personal errors. Ikaw na yung may mali. Okay. So ano yung mga pwedeng examples niyan? Based on experience na lang. Kunwari, ito, pag nagta-titration tayo or gumagawa ka ng solution, standard solution, ang possible na source ng error doon is yung pag-read ng meniscus. Pwedeng nagawa mo yung parallax error, ibig sabihin hindi eye level yung meniscus mo, mali yung measurement mo. So, yun yung personal error. Ano pa? Pwede rin yun sa limitation ng experimenter. Okay, so kunwari, you are judging your samples based on color. Tapos color blind ka. Yun, personal error yun. So, pwedeng maging result yun ng systematic error. Okay? So, kunwari, sinusort mo yung mga chemicals, no? Then, ganito dapat yung color niya. Tapos ikaw, colorblind ka sa ganung color. So, mali, masusort out mong materials. Nangyayari yun sa lab. Yes. No? Especially when doing spectrophotometric analysis. Nangyayari yan. Okay? Although, very rare lang. Unti lang naman kasi mga colorblind naman na. So, kapag ganun, you ask for help. No? Kasi you have the limitation and you don't want to you don't want your results to suffer naman. So, okay lang magtanong sa kunwari, nag-work ka na. Okay lang magtanong, uy, colorblind ako. Baka you can help me distinguish these colors para yung results nyo, ano pa rin, accurate pa rin. Okay? So, nangyayari mga ganung bagay. May classmate akong ganun eh. Colorblind siya. Tapos di niya ma-distinguish yung ganitong color. Hindi ko na maalala kung anong color yun eh. So, yan. Nagkamali siya ng results. Tinulungan na lang namin. So, ganun. May mga personal limitations naman tayo. Hindi naman tayo perfect talaga, di ba? So, ibig sabihin, we have personal errors. No? And that can be corrected. Basta alamin mo lang, ay ako pala yung nagkamali. Oh, sorry po. Then you correct yourself na. Pwedeng you buy your new eyeglasses para mas malinaw yung readings nyo. You check kung ikaw ay nagpa-parallax error. So yun yung mga correctable. No? So those are the types of systematic error. Okay? So again, systematic error or determinate error, they are flaws na pwede mo makita and pwede mo makorek. Okay? So, ganun. Paano uli malalaman kapag may systematic error? Tingin ka lang sa standard deviation. Pag mataas yan, check mo uli kung ano yung mga ginamit mo. Okay? Excuse me. And then last one, we have the gross error. Okay. So, pag sinabing gross error, ito. Pag sinabing gross error, yung word itself, gross, ibig sabihin malala na error. Ito yung carelessness talaga, no? Maling-mali. Okay. So, ano yung mga example ng gross error? Kunwari, you are reading your volumetric flask, no? Tapos, anong nangyari? Let's say, burette na lang, nagtatitration ka. 'Di ba sa dulo nun tumutulo yung liquid sa dulo ng burette? Tapos biglang nabasag mo yon. Pagka-twist mo, nabasag yung ilalim. Dinatapon lahat ng liquid dun sa loob. Okay, sa loob ng flask. So, mali yon. So, tapos sinabi mo pa, ayoko na umulit ng experiment. Ito na lang yung result. Yun yung gross error. Maling-mali yun. Okay? So, when you have gross errors, ito yung mga measurement na mali talaga. This will lead to outliers. No? Outliers are the data, no, na malayo sa usual measurement mo. Super layo niya, as in. Okay, so ano yung mga ways to address gross errors? You can check whether may outliers ka or not. And may statistical tool for that. Okay? So mamaya ma-check natin how we will know if we have gross errors. Pag wala, di pwedeng systematic or random error lang yung meron. Okay? So in summary, we have three types of error: random, systematic, and gross. Pag sinabing random or indeterminate error, hindi mo siya pwede malaman. Kasi andun na talaga yan, nasa system na yan, nasa universe na yung error na yan. Okay? So that's okay lang. Walang solution for that. Pero kapag sinabi natin systematic error, you can determine saan nagkamali. Pwedeng personal, pwedeng sa system or sa methods, pwedeng sa instrument. So in order for you to address those errors, ano pwede mo gawin? Pwede ka mag-calibration, you use I don't know if na-discuss na sa inyo yung calibration techniques, no? Nasa yun eh, nasa lecture chapter 2. So kung na-discuss na, so alam nyo na yan. Pwede kayo mag-calibrate ng instrument, pwede kayo gumamit ng standard calibration, kaya just be careful. Yun yung mga ways to solve systematic or determinate error. Pag sinabi namang gross error, ito talaga yung malala. Super layo na nakuha mong data. So ano yung solution doon? Umulit ka na lang from the top. Okay, so ulit ka talaga from the top. Okay, so bakit important tong statistics sa chem? Especially sa ating field na nasa science. Kasi we are dealing with numbers, we are dealing with measurements, no? And we must assure ourselves, hindi lang tayo, i-assure din natin yung ating mga patient or yung magbabasa ng paper natin na ang ating measurement ay accurate. Kasi kapag nakita nila yung standard deviation mo ay malaki, hindi nila gugustuhin yon. Okay? So ayaw nila ng ganun kasi baka may gross error ka na, baka may systematic error ka pa rin dyan, hindi mo pa na-address. So ayaw natin ng ganun. No? Kapag kayo nag-thesis, pwedeng gisahin kayo dito sa standard deviation lang. Okay? So that's why nung ako nag-thesis, kung kailangan ko talaga ulitin yung experiment, inuulit ko talaga. No? So kaya noong thesis days ko, siguro sa isang buong linggo, papasok ako ng school from 6 a.m. until 9 p.m. Minsan no lunch pa. No? Walang kain-kain, gabi na lang ikaw kakain. Kasi you want to make your results reliable. Kasi ang kapalit nito, kunwari nasa industry ka, ano yung pwede kapalit niyan? Yung pangalan mo. Okay? So baka pag nag-apply ka ulit sa other companies, machika nila, oy, si ganito, maraming yan, personal error yan. Kaya gumagawa ng gross error yan. We don't want that to be associated with our names, no? So that's why when doing measurement, no, we must always check excuse me, we must always check yung statistics natin. Okay? Tignan natin kung mababa yung errors natin. Okay? So, one way to solve for the errors is ito. One way to check if you have errors ay standard deviation. Okay? So, when you say standard deviation, this is the measure of the closeness or the scatteredness of your data. Okay. So suppose you have data points na scattered, kalat-kalat yung values mo, then your standard deviation will be huge, no? So ayaw mo yan ilagay sa thesis mo. Huwag mo ilalagay yung malaking standard dev, no? So ulit ka na lang ulit until you come up with something that is good. Okay? Kasi kunwari you are publishing papers, no? When you are publishing your research paper, pwedeng hindi ma-accept yung paper mo because of your standard deviation. Ganun kasi sa chem, no? So, kailangan lahat ng curves, no? Lahat ng graph, merong error bars. Makikita dapat yung standard deviation. Pag malaki yon, cancel, no? So, wala. Hindi ka tatanggapin. Sayang yung paper mo. Nagbayad ka pa ng 100 euros for that, di ba? Okay. So, nangyayari yan. Okay. So, bago ka mag-publish ng inyong paper o kaya ng iyong thesis or ng iyong research, you must check first whether your data are close or not by using the standard deviation. Okay. So, yan. If malaki yung standard deviation, pangit yon. Okay. So, pwedeng pwedeng may systematic error doon. Okay. Or pwedeng may gross error doon. Okay? So, yun yung mga pwedeng maitulong sa atin ng standard dev. Pag malaki yan, systematic error o kaya gross error. Yung random error kasi andyan na talaga yan. No? So, wala kang magagawa doon. So, dalawa lang yung options mo. Okay? Pwedeng gross, pwedeng systematic. Okay? Pag mababa yung standard dev mo, then okay yan. So, good yan. Wala masyadong errors sa inyong data. Pwedeng yan, random error lang. Okay? Another tool is the relative standard deviation or RSD. Ito naman, it's going to compare your standard deviation with the average, no? or the mean. Kapag malaki yan, then there's something wrong with your data talaga. Pag mababa yan, then that's okay lang. Okay? So, ganun lang. So, in order for us to solve for the standard deviation, then we must get the square root of the sum of your measurement minus its average squared divided by the number of measurements minus 1. Or in formula, that's the square root of sum of x minus x bar square all over n minus 1. Okay? So, paano sinusolve yan? Mamaya magpa-practice pa tayo, ha? Uh, chill lang kayo. So, suppose you have this data points. Ito yung kanina pa. At nakuha natin yung average niyan, di ba? 315.2. So, in order for you to solve for the standard deviation, you must check first yung sum ng x minus x bar squared. Paano yon? So, gagawin mo, your x is your data points. Ito yan, data point mo yan. Then, kukunin mo yung difference ng yung data and yung average. Okay? So, ano gagawin mo? This is your data point. Isusubtract mo yon sa average. So, you will get x minus x bar. So, yun. Gaganan mo yan. Then, what's next is that i-square mo yon. So, you will square this number, this one, that one, blah, blah, blah. Then, you will add them up. So, kapag pinag-add mo na yung column na to, you will get your sum of x minus x bar squared. Then, ano na lang gagawin mo? You will plug it in the standard deviation formula. Papasok mo yun doon. So, you will get standard deviation. If masyado tong malaki, pangit yon. Kunwari, nag-100 ka dyan, no? Maling-mali yan. Most likely, may gross error doon. Pero kapag ganito lang, medyo mababa lang, pwedeng systematic error yan. Okay? So, ganun. Mafe-feel mo naman kapag masyadong malaki yung standard dev mo. No? So, paano mo mafe-feel? Just use the RSD. Titignan niya yung ratio ng standard dev mo with your mean or your average. Pag etong value na yan, lumagpas yan ng 1, maling-mali yung measurements mo. Okay. Pero kapag yan ay mga decimal lang or at least 0.05 below, that's good. Okay. So, ganun lang. So, mamaya may worksheet tayo for this one, ha? Stay put lang kayo dyan. And then, kunwari, malaki na talaga yung standard deviation mo, ano yung pwedeng source ng error kapag masyadong malaki standard deviation? It could be systematic or it could be gross error. Okay. So, yung systematic, hindi mo agad masasabi yun eh. Pwede mo magawa muna is that pag nakita mo malaki yung standard deviation mo, you may want to check whether you have an outlier or not. Okay? So in order for you to check whether may gross error ba or wala, you must do this test, no? This is the Grub Test, no? Actually, dalawa yung pwede mo gawin dito. Pwedeng Grub Test, pwedeng Q-test. Q-test lang talaga yung pangalan niya. Okay? So these two statistical tools tells us whether we have an outlier or not. Okay? So paano mo malalaman if you have an outlier or not? Okay, so you will use this formula for Grub's test, that is G calculated equal to the ratio of anyway, may nag-email lang. So that is the ratio of your questionable value minus the average in absolute value divided by the standard deviation. So ganito gagawin mo. Kunin mo yung absolute value ng difference ng questionable value mo minus the average all divided by the standard deviation. Sir, ano po yung questionable value? You're going to assign that. Okay? So from your data set, you will arrange them from lowest to highest. Then, kung sino yung mga nasa dulo, sila yung mga pwedeng, sila yung mga pwedeng questionable value. Yung pinaka-lowest and yung pinaka-highest na value. So they are the possible questionable values for your measurement. Okay? Hindi pwede yung nasa gitna kasi nasa gitna yun eh. Yung mga nasa dulo lang. Okay? So after solving for your G calculated, you are going to compare that with the G tabulated. Ito yung G tabulated. So kailangan may copy kayo nito. So this is the G tabulated. This will tell you the acceptable value for G. Okay. So kunwari, you have 7 data points. So hanggang dito lang dapat yung value ng G calculated mo. Pag lumagpas yan sa G tabulated, kapag yung na-solve mo yung G dito, lumagpas dito sa nakalagay sa table, then that means you have an outlier and you have to remove that. Okay? Again, if your G calculated is greater than the G tabulated, ito yung G tabulated, pag mas malaki yung na-solve mo doon, ibig sabihin may gross error ka. Okay? And you have to remove that measurement. Okay? You may want to redo your experiment again. Okay? Pero if your G calculated is less than the G tabulated, then you do not have any outliers. So that means ang cause ng mataas na standard deviation mo is systematic error. Okay? So you may want to check your instruments, you may want to check your methods, and of course yourself, no? Pwedeng ikaw na kasi mismo yung nakagawa ng error. Okay, so again, how are you going to identify kung anong type ng error yung nagawa sa experiment? Number one, you check for outliers first because outlier will tell you if there is a gross error. If there are none, pag walang gross error sa inyong calculation using Grub Test, then most likely you have systematic error sa inyong measurement. No. So, tatlo lang naman yon. You may want to check your methods, instrument, and ikaw no, in order to minimize the big standard deviation. Okay? Pero kapag mababa yung standard deviation mo, then be confident kasi okay yan. So, ganun lang ha. Suppose we have this value. Okay, so, students dissolve zinc from galvanized nail, blah, blah, blah. Okay, so this is the measurement. So, we have 12 data points here. So, for you to be able to see kung sino yung pwedeng questionable value mo, you may want to arrange them from lowest to highest. Mas madali kasi makikita yung kapag ganun lowest to highest. Pero for this case, di natin in-arrange eh. So, pwede mo gawin dito para ma-check mo kung sino yung questionable value. Tignan mo kung sino yung weird sa compared to other data points. Example, ito, 10, 10, 11, 9, 9. Biglang may 7. Tapos balik uli sa 10, 9, 11, 9, 10, 11. So, mapapansin natin, all other values are 10, 9, and 11. Pero may nag-iisang 7. So, that will be your questionable value. Yung parang off siya. Pag nakita mo siya, parang ang weird naman. So, that is your questionable value. So, to test whether this number is an outlier or not, you can use the formula for the Grub test. Excuse me. So, kinuha na niya yung mean and standard deviation. So, basically, what we're going to do is to plug in all the values. Your questionable value is the 7.8 kasi siya yung weird. You will subtract it with the mean and the standard deviation which was calculated earlier. Okay? Kunin mo yung ratio ng dalawa and we solve for G calculated equal to 2.13. Okay? Then what's next? Kung ano yung G tabulated mo, tingin ka dito. So since we have 12 points, so the acceptable value for G ay 2.285 na 2.285. So hanggang dyan lang pwede yung value ng G. Pero kapag lumagpas yon, outlier yon. Tignan natin. So our G tabulated is 2.285, pero yung na-calculate natin ay 2.13. Since G calculated is less than the tabulated, meaning nun, the questionable point is not an outlier. It should be retained. Okay? So hindi mo siya buburahin. However, if in case na lumagpas to sa G tabulated, nari 2.30 yan, then it will tell you that your data point is an outlier, and you must remove that number. Okay? So, kailangan mo tanggalin yung number na yan. Okay? So, ganun. Kailangan, when dealing with numbers, hindi lang basta-basta nagba-magic. Kasi ginagawa ng iba, kunwari, you have data points, tas may isang nagpalaki ng standard deviation. Yung iba binubura lang bigla. No, wag nyo gagawin yan. Okay? Kasi kapag ginawa nyo yon, you are assuming na walang error sa measurement nyo. So, what you're going to do first is to check the standard deviation. You check if meron kang outlier. And then, kung merong outlier, you redo the experiment, no, for that trial. Then, kapag walang outlier naman, then you check your methods. Baka may mali, no? Okay? So, yun. So, ganun lang. That's it. That's how we use statistics, no, for us, no, to do accurate or and precise measurements, no. So, magagamit nyo yan kasi medtech kayo, no. So, when you are doing, chemical analysis, no, let's say blood chem, no. Okay. Kunwari, nasa clinical chem na kayo na part, no? Pag yung result nyo, magkalayo-layo talaga sa isa't isa, then may mali talaga yon. Okay? So, alalahanin nyo na lang yung types ng error and how to resolve them. Okay? Paano mo malalaman kung may gross error? You check for the outliers using Grub's test. Pag walang outlier, most likely, merong systematic error lang. Okay? And that can be addressed then. Okay? Ang goal kasi natin dito is for us to be able to have reliable results, no? So, yun yung gusto natin sa Anachem. Reliable yung results natin. Not only an Anachem, but sa lahat din. Okay? So, it is important na alam natin yung calibration and alam natin kung paano mo malalaman yung types ng error, no, using statistics. Okay? So, ano yung mga tools na pwede gamitin natin? Grub Test and Standard Dev. Okay? So, yun yung mga pwedeng tools na gamitin to check whether there are errors or not. Okay? Okay, so we are almost done. Okay, so to end this day, sagot na lang tayo ng isang item sa worksheet. I will leave the other item sa inyo, no, para kayo mag-practice. So, in answering this item, I will give you three ways to answer this. Number one is yung manual, which is yung gagawin muna natin. Second one is using the calculator technique. And then, yung isa pa, using Excel naman. Okay? So, if you have your calculators with you, please open them. Sabayan nyo ako mag-solve dito. Okay? So, from our data set, number one, solve for the mean, median, mode, and standard deviation. Number two, identify whether there is an outlier. If there are, you solve for the mean, median, mode, standard dev. If the outlier is to be eliminated. Okay? Kapag wala namang outlier, then wala ka nang gagawin. Okay? So, so ganun gagawin natin. Solve muna natin yung mean, median, mode, STDev, standard deviation, and then later on, we will see whether meron tayong outlier or wala. Kapag may outlier, tatanggalin natin yon, and then we will solve natin uli yung mean, median, mode, STDev. No? Titignan natin kung bababa yung STDev, standard dev. No? Pero kapag wala tayong outlier, edi yun na yun. Wala tayong gagawin ng iba. So, this is our data point. We have the water hardness profile in ppm. So, we have 10 data here. 325, 396, 345, 336, 384, 305, 369, 328, 384, and 357. So, in order for us to solve for its mean, median, mode, and standard deviation, gawin nyo muna is ganito. You may want to arrange your data muna from lowest to highest. Okay, so arrange natin siya from lowest to highest. So we have here 305 first. Siya yung lowest number. Okay, so okay na yung 305. Ano kaya susunod? 325. Then, followed by 328. So, ganito yung una yung gagawin nyo, ha? Arrange them from lowest to highest muna. Okay, so let me arrange them this muna para tuloy-tuloy na tayo. Wait lang, ha? 328, 325. Okay, so yan. In-arrange ko na yung data. Sana kayo rin nag-arrange na. Huwag nyo lang titigan yung screen. Okay, so solve din kayo, okay? Sabayan nyo ako para sabay-sabay tayo. Okay, so I arrange our data set, no, from lowest to highest. 305 being the lowest, 396 being the highest. Okay, so yan. What's next? So, punta muna tayo sa number 1. We solve for the mean, median, mode, and then standard deviation. Okay, so let's solve first for the mean. Again, the formula for mean, ito yan, x bar, that is equal to the sum of x divided by n, the number of your data points. Now, so what we want to do first is to get the sum of the value of x. So ito yon, i-add natin yan lahat. So, paki-calculate na lang din muna and check if same tayo ng ng sum. So, i-add ko muna ta. Wait lang. Okay, so the sum of the value of x is 3,529. So, please check kung ganun din yung nakuha nyo. Double check ko lang ulit. Wait lang. Okay, so ito talaga yung sum niya. 3,529. So, for us to solve for the mean, so that is the sum of x divided by the number of your measurements. Okay, so that is 3,529 divided by 10. Kaya mo na yan i-mental. That's 352.9. Okay, so this is our average. Next one would be the median. So how are we going to obtain the median? So since we have 10 data points here, ibig sabihin, may kukunin tayong average sa gitna. Okay. So, i-arrange mo muna yung numbers, lowest to highest, and then at each end, yung lowest pati yung highest end, ika-cancel mo sila until you arrive sa middle portion ng iyong measurement. Okay. Then, kukunin mo yung average na yun kasi even number tong measurement natin. So, ito yung lowest, ito yung highest. Cancel ko muna sila. Ito, cancel ko muna. Then, yung susunod. Yung susunod. Yung susunod. And then, lastly, napunta na tayo sa dalawa sa gitna. So, ito yung inaasahan natin. Kapag odd number yan, isa lang yung matitira. Kapag even number, may dalawang matitira. Okay. So doon natin kukunin yung ang tawag doon? Doon natin kukunin yung median. Okay? So, For even numbers, what we're going to do is that yun dun sa dalawang natirang number, kukunin natin yung average nun. Okay? So for median, that will be 345 plus 357 divided by 2. Okay, so yan. So kunin natin yung average ng dalawang numbers. So that's 351. And take note that the median and the mean are magkadikit. Magkalapit lang sila ng value. Okay, so ayan. How about the mode? Pag sinabing mode naman, kung sino yung pinaka-frequent. Okay? So, tignan natin yung ating dataset, kung sino yung pinaka-frequent yung value. Okay? So, obviously, that's 384. Kasi siya lang yung number na nauulit. Yung iba, hindi na. So, this will be our mode. 384. Sir, paano kapag walang nauulit? E di, walang mode. No mode. Okay? So, ganun lang. So, this is the mean, sum of x divided by the number of measurements. Median, kung ano yung nasa gitnang measurement. And then mode, kung ano yung pinaka-frequent na measurement. And then, next one, we have the standard deviation. I will call it STDev para shortcut. So, in order for us to solve for this standard deviation, we have to fill out this table. Fill out natin to completely. Okay? So this is the first column. The value of x is here. On the next column, we have the x bar or the average. What we're going to do is just to copy the average and lalagay natin yung average dito. So ano ba yung average natin? 352.9. So i-plug in natin lahat ng 352.9 dyan. So ganito yung gagawin nyo muna. Okay, so yan, ipa-plug in mo yung average dito. So yan. On the third column, you have your x minus x bar. So what does that mean is you're going to subtract this and these numbers. Okay, so x minus x bar. So pag subtract mo lang yung dalawang yan. So gagawin mo yan sa lahat. Okay, so give me some time. Kayo rin, mag-solve kayo ha. Pindutin ko lang sa calculator to. Okay, so yan, na-subtract ko na yung x minus the x bar. So, isahin nyo po talaga yan. Okay, so this minus that equals this and so on and so forth. Then what's next is we're going to fill out the last column, which is the square of x minus x bar. So basically, on our last column, you're just going to square what's written on the third column. So square mo lang yan. So that also means mawawala yung negative sign. Okay? square mo lang yung number. Okay? So let me do that ulit. Again, yung negative values, mawawala yan ha. So, type mo lang yung number, then square mo siya. Okay, so, ayan. So, na-square ko na yung mga numbers sa third column. And hopefully, same tayo na nakuha na sagot na. What's next? Ang next is, recall the standard deviation formula. That is the sum of x minus x bar square. So what we're going to do is that for the last column, we are going to add them. Pagsama-samahin natin yung mga yan. I-add natin sila. So yan. Let me add them na lang muna. So add nyo rin ha. Okay, so na-add ko na lahat. Please check na lang kung same tayo ng sagot ha. So the sum of x minus x bar square will be 8,108.9. Let me double check lang. Kasi pag hindi mo na double check yan, mali yung masasolve mo. Mahirap na. Ang daming numbers eh. Okay, so that's 8,108.9 talaga. So what's next? So since we know the value of the sum of the x minus x bar square, we can now proceed with the calculation for the standard deviation. Okay, so again, the formula for standard deviation is that is the square root of the sum of x minus x bar square divided by n minus 1. Your excuse me, your n is the number of your measurements. Okay, so plug in na natin yung values. So we have, what is the sum of the x minus x bar? Again, that's 8,108.9. And then n minus 1 on the denominator. So we have 10 data points, so that's 10 minus 1. Okay, so that will be 10 minus 1. Pakisolve na lang sa calcu and round it off to 2 decimal places. So that will be 30 0.01647 something. 2 decimal places na lang tayo. 0.2. So that is our standard deviation. Okay? So, ganun lang. Yan na yan. So that's how we solve for the measures of central tendency and the standard deviation. Medyo malaki yung standard deviation, ha? That's 30, 30 ppm is malaki. So, okay lang kung 1 digit lang. 5, 6, 7, 8, 9, pero kapag lumagpas na ng 10 yan, that's kinda questionable na. So, as you can see, we have high ST dev. Mataas ang standard deviation natin. That means our data are spread out. Obvious naman eh. So, we started from 305, ang ending 396. So, kalat na kalat yung data natin. Okay? So, since mataas ang standard deviation natin, there are two possible uh, sources of error for that. No? Pwedeng meron tayong systematic error, pwede tayong merong gross error. Okay? So, ano yung unang gagawin mo para malaman mo kung anong type ng error yung meron dito? Check mo muna yung gross error. Is there an outlier in our measurement? Di natin sure. So, punta tayo sa number 2. Let us identify whether there is an outlier. Okay? Check natin kung may outlier. Again, di ba, sa formula ng G-test, let me write it here. Di ba, you have your questionable value minus the average divided by the standard deviation. So, yung questionable value mo, if you arrange your data points from lowest to highest, it could be the lowest number or it could be the highest number. So, yung mga nasa gitna, hindi yan yung mga outlier. Yung mga nasa dulo lang. Okay? So, tignan natin. Suppose, gawin natin questionable value si 305. Okay? So, kunwari siya yung aking QV, questionable value. So, that will be 305 minus, what is the average? 352.9 divided by the standard deviation, which is 30.02. Let's solve for the G calculated. Yung absolute value, ibig sabihin nun, walang negative, ha? Okay, so the G calculated is 1.596. 3 decimal places kasi yun nasa table ay 3 decimal places din. Okay, so that's 1.596. Yan yung G calculated natin. Now, kunin natin yung G tabulated. Balik ulit tayo sa PowerPoint. Okay, so wala na yung PowerPoint. Buksan na lang natin ulit. Okay, so this is our G table. So since we have 10 measurements, 10 yung measurements natin. Excuse me. So this will be our G tabulated 2176. Okay, so kung ilan yung measurement mo, yung corresponding G value yung basis mo for the G tabulated. 2176. 2176. 2176. Okay, so what's next? You are going to compare your G calculated with the G tabulated. Sino mas malaki? Obviously, yung G tabulated. So we can say G calculated is less than the G tabulated. What does that mean? If your G calculated is less than your G tabulated, then 305 is not an outlier. So, hindi siya outlier. Okay, so yung 305, andyan talaga yan. Okay, so that is not an outlier. So, wala tayong outlier sa lower end. How about the higher end? Ito, ligtas siya. So, hindi siya outlier. Tignan natin yung 396 kung outlier yan. Okay? So, basically, palitan mo lang yung 305 ng 396. Outlier ba yan? Tignan natin. Solve lang natin ulit. Okay, so hindi rin siya outlier because the G calculated is 436, 1.436, still less than the G tabulated. So that means we do not have any outlier for our measurement. So anong type ng error meron dito? Ang laki ng standard dev eh. So since we do not have any outliers, then we do not have gross errors. Ano na meron? Systematic error. Okay, so most likely systematic error yung nandyan. It could be from instrument, it could be from the methods, or it could be personal. Okay? So ganun po natin may infer kung saan may mali. No? Just use the statistics. No? So most likely ganyan yung quiz nyo. So I will give you data, then from those data points, kayo mag-decide anong type ng error meron dyan. So kayo bahala doon. Okay? So, you may want to take screenshots. That's okay. Screenshot nyo na lang yan. So, again, wala tayong outlier. So, lahat ng value ay retained. Wala tayong buburahin na value. Ayan. So, pwede nyo i-screenshot yan. Okay? So, we're almost done. Kasi nakwento ko na yung long method. So, this is the long method. Ang daming sinasolve. Ngayon, let's go with the shortcuts. No? So, punta tayo sa shortcut. Kasi, wala lang. Shortcut tayo. So, tuturo ko sa inyo yung calculator technique. Kunin ko lang tong copy ng PowerPoint sa Canvas. Ay, copy ng worksheet. Kasi wala akong copy dito. So, tuturo ko yung calculator technique. Open na natin yung camera. Hopefully, malinaw sa inyong end yung camera. Check ko lang yung worksheet para ma-type ko dito. This will only work if you have Casio ClassWiz na version o kaya 991ES Plus, 991ES, 570ES, 570ES Plus. Basta yun yung type ng calc nyo, this will work. So Sharp, I don't know if paano. I do not like Sharp na calculator talaga. Hindi kami magkaunawaan eh. Kaya hindi ko siya ginagamit. So Casio talaga yung preferred na calcu sa science. Na. Madali lang kasi siya gamitin. Okay? So I have my data point here. So ayan, binuksan ko lang. Ang pwede natin magawa dito sa calculator is to solve for the standard deviation and the mean. Okay? So let me teach you how to do that. If you all know this already, you're good to go. Okay? Pero pag hindi pa, so ito na yun. Hopefully malinaw sa inyong screen yung camera. So far mukhang malinaw naman. May delay nga lang. Okay, so for you to solve the problem, especially dun sa standard deviation and the mean, pwede natin gamitin yung statistics function ng calculator nyo. So if you want to use the stat function of your calculator, just press the mode, itong mode, and then you're given with lots of menu here. So you have the comp, I don't know kung ano meaning yan. Number 2 is the complex. Complex values, ibig sabihin may mga I, no? plus minus I. No? Kasi alam natin, I square is negative 1. So, dun siya. Sa complex numbers yun. Number 3 is the statistics. Yun yung gagamitin natin. Number 4 is for base n. So, usually that's logarithm. Number 5 is equation. We will need that pagdating natin sa acid, sa equilibrium. Number 6, we have the matrix. Alam niyo yung matrix, yung kung ano kayo, linear algebra, yun. Yun. Basta yun. Yun naka-parenthesis. Tapos may mga numbers sa loob. So that's the matrix. Then we have the table and the vector. For the purpose of analytical chemistry, we will need to use the stat and the equation function. Okay, so ito lang, stat and equation. Tuturo ko rin sa inyo paano gamitin yung equation, ha? Pero sa ngayon, stat muna tayo. So to access stat, press 3. And then you are given with another set of another set of options here. We have 1 var a plus bx, may cx square, ln x, e raised to x, a b raised to x, something. Okay, so let me just walk through some of those. 1 var, that means isa lang yung variable mo. So that means isa lang yung value mo. Yun yung gagamitin natin. For a plus bx, ito yung ginagamit for equation of the line. So we can use this for linear regression. Hindi na natin didiscuss yun. Pero sa biostat nyo, makakwento yung a plus bx na yan. Okay. So that describes the slope of the line, and you can get the Pearson correlation coefficient with that. For number 3, you have your quadratic equation. Parang ganun din yon sa number 2, sa linear. But this time, quadratic siya. Number 4, you have your logarithmic function, exponential function, and other types of functions. Okay? So again, ang kailangan lang natin dito is yung 1 var. Okay? Isa lang kasi variable natin. So yan, so when you press the 1 var, ito yung lalabas, you have the x, and then you can plug in your data here. Okay? So, di ba parang ito lang din yung nandito sa ating worksheet, yung x. Okay, so ayun din yun. The calculator will solve for the other stuff na. So what we're going to do here is that we're going to plug in our values dito sa loob ng table na to. Paano yan? So I have a copy of my worksheet here sa kabila. Ganito lang gagawin nyo. For example, 325. Para ma-plug in mo yan dito sa calculator, you type in 325. Type mo lang yan, then press the equal sign. So, nasa loob na siya ng table. You do that for the other 9 numbers. 396, 345, equal sign, 336, 384. Be careful lang pag nagtatype. 384, okay. 305, 369, 328, 384. Ay, pag may mali, 387 na type ka instead of 384, you overwrite that number. You can use this button to move along the cells of your table. Okay? Saan ako nagkamali? Ito, 384 yan. Overwrite mo lang. And then you have 357. So yan. Andito na yung 10 digits natin. 325, 396, 345, 336, 384, 305, 369, 328, 384, and 357. Okay? So, para makuha mo yung statistical calculations dito, you press the on button. Press mo yan. Wala na. Okay. So, ano susunod mong gagawin? Pag nawala na yan sa screen, next is to press the shift and the stat button. So, asan yung stat button dito? Zoom in ko lang. Ayun. Sa 1, may makikita kang yellow na stat. Na. So, we want to access that. So, you press the shift followed by 1. Okay? Pag napindot nyo na yan, ito yung lalabas. We have the type, the data, sum, variance, distribution, min, max. So, for these, for the mode of central tendency and the deviations, no? So, you want to press the var. Yung var. Ibig sabihin nun, yung variance. Okay? So, press natin yung 4. Okay. So, we have four options here. Number 1, this will tell you how many data points you have. Yun yung n. Ilang data points meron tayo? 10. Okay? So, madali lang naman yun. Bilangin mo lang eh. Number 2, that is the x bar. So, that's the mean. Okay? So, check natin. Kapag pinindot natin yung 2, it should give us the mean. So, press 2. Nakalagay x bar. Para lumabas yung number, you press the equal sign. Ito. So, that's 352.9. Ito yung nasolve natin na mean, di ba? Di ba? Easy lang. Okay? So, balik ulit tayo sa stat. Next one, we have the sigma x. The sigma x is the population standard deviation. Ano yung problem with population standard deviation? Iba yung equation niya sa standard deviation na ginamit natin. So, we will not use this sigma x. Rather, we will use Sx. Itong Sx, ito yung standard deviation with the formula na ginamit natin kanina. Again, not this sigma x, itong Sx ang gagamitin natin. So you press 4, and then you press the equal sign. Diba ito rin yung standard deviation na nakuha natin. So that's 30.02 when rounded up to 2 decimal places. So ganun lang po yung calculator shortcut. Then yan, you can use that to solve for the Grub Test and other stuff na gusto mo gamitin. And the last one, yan, so tapos na tayo sa calculator techniques. The last one that I want to share with you is yung Excel. Okay, so Excel tayo. Pag gusto nyo uli-ulitin yung yung sa calculator technique, panoorin nyo na lang yung video natin sa YouTube, okay? Last one, bukas tayong Excel. Ito, na-type ko na yung values. Kunwari wala kayo nakita. Ayan. So using Excel, you can type in all your digits here. Type ko lang. Okay, parang accountant ako dun . Okay, so this is our data. Okay. If you want to arrange that from lowest to highest, ano gagawin nyo? You highlight your numbers, you go here sa sort and filter. Hindi ko mabasa eh. And then you sort it from smallest to largest number. Okay? So automatically mag-arrange yan from smallest to highest. Okay? So turuan ko kayo ng shortcut. If you want to solve for the x bar or the average, you press equal sign, then type in average, open parenthesis, and then you highlight your number. You highlight your data. Again, equal sign, average, open parenthesis, your data set. Press enter, you will have your average na. Yun na yan. If you want to solve for the standard deviation, ito naman, equal sign. Kaya ang tawag ko sa standard deviation ay stdev kasi yun yung ito type mo dito, stdev. Okay? So you will type stdev only. Huwag nyo pansinin yung mga nakalagay doon. Just stdev, then open parenthesis, highlight your digits, and press enter. Ito din yung na-solve natin kanina, di ba? 30.02. So, yun yung shortcut. Again, for average, ito yung equation. Equal sign, average, open parenthesis, your data set. Then, enter. For the standard deviation, that is equal sign, stdev, open parenthesis, highlight your data, press enter. So, ganun lang. O, kunwari naman, you're going to fill out our worksheet, no? Paano yun? Gayahin mo lang yun nasa worksheet. So, you have your x, you have your x bar, then x minus x bar, and then x minus x bar squared. So, for the x bar, copy mo lang yung 352.9. And then, if you want to, to make this number copied sa ating column, click mo lang itong maliit na square doon. So, magbabago yung cursor from malaking cross, magiging manipis na cross siya. And you double click it. Okay? So, double click mo lang. Mag-fill yung Excel niyan. O kaya, pwede mo naman i-drag. Okay? So, iisa yung number niyan. Then, what's next? Let's have x minus x bar. So, ito yung x bar. Subtract natin sila. So, that will be equal sign, open parenthesis, and kahit wala na palang parenthesis. X minus, this is your x bar, then enter. Then you may want to drag this para makopya yung equation. Okay? What's next is that your x minus x bar is square mo siya. So, paano yon? You press the equal sign, you select the cell, I think x minus x bar, then para ma-square mo yan, you type in yung ganitong symbol sa calculator niya. Yun nakapag ganun. Hindi ko alam kung ano tawag dyan eh. Pero yan, ayan. Nandiyan yan sa keyboard niya. Tignan nyo lang, asan yung pag ganun. Okay, so ito sa akin. Then you press 2, that will be your exponent, squared eh. And then drag this ulit pababa. So ito din yung nasa ating worksheet, di ba? Then later on, you're going to add all of this. So kunin mo yung sum ng x minus x bar square. So that will be equal sign. Then type mo sum, open parenthesis, highlight mo ulit ito lahat, and press enter. Ayan. Galit na galit sa keyboard. And then yung ating sum of x minus x bar squared. Okay? So again, that will be equal sign, sum, open parenthesis, highlight your cells, then press enter. You will get 8,108.9. Okay? And to solve for the standard deviation, kung ayaw mo ng shortcut, edi ano yung equation ulit? That's equal sign SQRT. SQRT will allow us to get the square root. Okay? That's the square root of the sum. Okay? Divided by n minus 1. So what's n? 10. Minus 1, that will be 9 na lang. And then you press enter ulit. Okay, teka lang. May negative sign ako nalagay sa harap. Okay? Ayan. So, again, so that is equal sign square root of your sum of x minus x bar square. Select mo na lang yung cell na yun, divided by n minus 1. So, in our case, that's 10 minus 1. So, 9 yan. You press equal sign. And if you round it up natin yan. So, that will be 30.0210. Okay? So, ito yung mga methods, no? Pwede kayo mag-manual. When I say manual, yung ginawa natin, yung ginawa natin na sinulat natin lahat. Ang problem lang doon, it is prone to errors, no? Especially pag nagsusulat kayo, and time consuming. Other methods, yung alternatives natin is yung calculator It can solve for the standard deviation very easily. No? And then last one is yung Excel. Kayo na bahala gumamit niyan. Okay? So pagdating nyo ng thesis nyo, magaganyan-ganyan din kayo. Gamit kayo ng Excel to calculate your results, no? So ganun. So paki-master na yung Excel, ha? So pakita ko sa inyo yung data ko sa thesis dati. Kasi nakakatuwa lang siya. Okay. So, yan. So, ganun lang ha. Masterin nyo na yung Excel ngayon pa lang. Kahit yung basics lang. Para pagdating ng thesis nyo, easy na lang. Okay? So, yan. So, share ko lang yung data ko ng thesis ko. Super dami niyan eh. Okay. So, yan. This is my gel fraction, pH optimization, bulaga, ang daming number. Diba? Saya-saya. And then, i-graph mo siya. Kinetics data ko, bulaga, ang daming number. Ayan. So, ang daming graphs, no? So, alamin nyo na yung mga paggawa ng equation, pagkuha ng intercept, etc., etc. This is my adsorption isotherm on thesis. Ayan. Oh, you have to include the error bars. Okay, so for this experiment, bababa yung error bar ko. However, for this one, medyo mataas, no? So, yan. And may application, ayan, unti lang. Then, pwede ka rin mag, dito. Di ba gumagamit tayo ng SPSS? Kung alam niyo yung SPSS, ako medyo nalilito ako doon eh. You can also use Excel to do the t-test. Okay, so pwede kayo mag-t-test dyan. Basta you enable the stat function of your Excel lang. Okay, so andito yun sa options eh. Dito sa options, i-check nyo lang yung statistics. Then you can do stats na dito. Pwede ka mag-F-test, then T-test. No? Yan. So, yun yung ginamit ko nung nag-thesis ako. Hindi na ako nag-SPSS. Nalilito ako dun eh. Okay? So, yan. Pag nag-thesis kayo, ganyan din yung buhay nyo. Ang daming numbers, daming interpretation, etc. So, good luck. No? And pag nag-experience nyo na to, dito nyo malalaman yung importance ng statistics no, sa buhay natin as researchers no, and scientists in the future. Okay? So, hopefully, nakakuha kayo ng tips sa akin today. And with that, tapos na po tayo sa chapter 2. By next week, chapter 3 na tayo. Okay? So, thank you for attending today. Kung gusto niyo ulitin yung yung shortcuts natin, yung mga tinuro kong methods, especially sa calculator, rewatch niyo na lang yung video na to. No? Upload ko to mamayang gabi sa YouTube. Okay? So, thank you very much. If you have any questions, don't hesitate to message me na lang. Yes, let's have Maria Suzanne.
Sir, late po kasi akong pumasok. Tanong ko lang po kung yung sa quiz po ba na natapos na, i-open niyo po ba yung answer quiz?
Yung for latecomers, yes po. For latecomers, I'll open the assessment sa kanila lang next week na. Pero yung sa mga nakapag-take na and bababa yung score, magkakaroon tayo ng bonus questions. This is open for everyone. Okay, so 5 questions lang yon. Let me, i-open ko yon kasabay ng sa latecomers natin. Okay. Sa latecomers, ako na yung bahala mag-arrange sa inyo. Okay. Sir, bibigyan niyo po ba yung answer key nung last quiz? After na lang mag-take ng latecomers. So, most likely, next week ko pa siya i-release yung answers. Okay, so any questions pa? So, bali ganito, next week, i-open ko yung for latecomers kasi di naman din nila kasalanan na yung Canvas lately, di ba? Maski ako, nagulat din ako sa Canvas eh. Bigla nawala. So, nawala rin yung announcement sa iba, no? So, ganun na lang. Ako na bahala mag-arrange sa inyo ng schedule. Tapos, for next week also, mag-open ako ng quiz 2, pati ng bonus questions. No? Kung perfect nyo na yung quiz 1, wag na kayo mag-take ng bonus unless gusto nyo lang mag-try. Okay. Pero for those na mababa, yun, pwedeng i-take nyo yun para madagdagan score nyo. And again, hanggang dito lang, hanggang chapter 1 ko lang yan gagawin. Okay? Kasi for the future chapters, chapter 2, and so on, wala. Isang take na lang uli. No? So, ganun na lang. Just statistics, alam ko mape-perfect nyo yan. Dali lang. Okay? So, yun lang. Any questions pa po from the class? Or we good na? Okay, so I think wala na, no? So, ayan, so thank you for attending our class discussion. Hopefully, may nakuha kayo mga ideas, especially sa ating sa ating calculations. So, I'll see you again next week. By the way, announcement, Wednesday, Thursday, wala kayong classes because of the alternative class, no? So, every year, sa anniversary ng FEU, meron talagang alternative classes, no? So, yun. Isa ako sa mga mag-alternative class. Gusto yung malaman kung ano yung experience ko sa adulting, paano ako nakapag-diversify ng aking income, and yun. So, share ko yan dan. So, ayan, kita-kita na lang uli, and enjoy your day. Okay? So, ingat and stay safe. Bye-bye po.